Good afternoon, and thank you all for joining us for our webinar today. As one of our senior SOLIDWORKS application specialists, Ryan Beach takes us through a session on how to get the best performance out of your slow assemblies and drawings in SOLIDWORKS. Please keep in mind that, as usual, we'll save a few minutes at the end of the session for any questions you may have for Ryan. So throughout the webinar, go ahead and type your questions into the GoToWebinar panel on the right-hand side of your screen, and we'll do
can affect the open.
If we do run out of time, we'll certainly follow up with you afterwards to get you those answers. Okay, without further ado, I will pass things over to Ryan to get us started.
Thank you, Jess. So hello, everyone. Again, I'm Ryan Beach. I'm one of the senior application specialists here at CAD Micro. So I titled this Working with Slow Assemblies and Drawings, specifically because if I say large assembly, that can be a relative term. And so by saying slow, the idea is if it feels slow for you to work with, or you're waiting on SOLIDWORKS to do something, then in others, right, that will be a slow assembly or drawing. So that's hence the name of this presentation. So specifically, the goal of this is to look at tools within the assemblies and drawings and what we can do to work with them to make it faster. I'm not looking at so much of the ways to investigate. If you want to know more about that, we can provide some of the documentation afterwards. So again, the agenda, the first part is I'm going to look at some SOLIDWORKS tools. And then the second part is we're going to take a look at some macros. And this is the part where I really want everyone to stick around for, because there are some macros here which I highly recommend everyone should be using after seeing this presentation. Okay, so first, I mentioned we're not going to go too much into the theory or whatever else, but I do want to quickly go over opening up an assembly in resolve mode and what this flow, and here is like a flow chart of what would normally happen. So in this case, if we're opening up an assembly, first we're going to load it into memory. If there's any changes, where likely are, then we have to update those components. Then we've got to solve the mates. And if the mate's solved, then we can update anything in context. So this could be anything from patterns to sketches in context. Assuming nothing has moved, then we go on ahead and we go to generate our graphics triangles and our assembly is opened. And now for our drawing, we have to do, I'm going to switch back here, we have to do all of this 100%. Then we can start this in here, which is now I can update all the configurations referenced by the drawing. Then we can show the model and projected views and draft, solve all the views, so cut views, show cut edges, and then other items now, such as like your layers and fonts. And then finally, load the drawing. So again, so this is why you may find it sometimes where your assembly might load quickly, but your drawing might take much longer to load, right? Because now you're not just loading the active assembly configuration, but potentially multiple versions or your assembly loaded multiple times due to the cut views in various configurations that have to be loaded. So usual areas of slow performance. One's hardware, working from a network drive. So recently I did a test, and I highly recommend everyone should do this on their own machines as well. If you are working from a NAS or a network drive or server directly without using a way to cache the files locally, what I noticed was for my own testing, the open time was more than double. So I had a large assembly of about 8,000 components. The open time locally took about a minute. Opening from the network drive ended up taking over 2 minutes to load, which I was kind of surprised about. And that was, my network drive was also running a solid state drive, so I gave it the best possible chance of opening quickly. And it still took more than double the amount of time, which I was really shocked about. So again, highly recommend that everyone should be looking at using something like file management system, for example, PDM, cache files locally. I mean, again, it's more than one reason behind why you should be using PDM, but that's just the big one in terms of performance as is. The next one is antivirus and firewall. You want to make sure that for your antivirus and firewall that you do tell your firewall and your antivirus programs to, hey, ignore the SOLIDWORKS files so it's not scanning them. That can help with increasing performance. You may not notice it hugely, but especially working over the network, it might have more of an impact. By the way, my testing here with hardware was done with my firewall and antivirus turned off. So I gave it the best possible chance of loading again. Next is old component formats. So again, if you have a library of components, they're from previous versions, make sure you update those to the latest version of SOLIDWORKS. Hopefully it's 2020. If not, I highly recommend you upgrade to 2020 for the new performance benefits. Next is large number of surface or solid bodies. So this is something I'm going to get to in a bit more in detail here with an example I came across recently. But if you have something which contains lots and lots of surface or solid bodies, this can, not always, but it can affect the open performance. And then I got right after that, large number of appearances. So this is an interesting one where if you have lots of appearances applied to a single file, that can make a big difference. But what I noticed was, and here's the really interesting part now that I'd like everyone to be aware of. If you have, for example, an assembly, let's say, or a part file, let's say 1,000 solid bodies, and let's say the solid bodies are relatively complex, and then you have an appearance applied to those, that file will take longer to load into memory than if it does not have any appearances at all. This is something which I have an active investigation with SOLIDWORKS right now. We're trying to figure out why that is the case. I currently do not know the reason behind it, but that is something to look out for. And I have an example which I can show in large designer view mode, where it's an extreme example of where instead of it loading in 7 minutes, removing all the appearances will load in about 14 seconds. So quite a significant difference. And then last is large component files. So again, another thing to watch out for, if your part size is quite large, and especially if you're working with over the network, then it's going to take longer again to try and load it into memory. Okay, so now I want to get into the tools here, which is large design review edit mode for assemblies and then detailing mode. So I mentioned this in my previous webinar, but I'll cover this again. So what I want to do is I want to close out of my assembly right now. I'm going to close out of my current drawing. And what we want to do is, and I highly recommend everyone should be using this, is this large design review edit mode. So if you're in 2020, you'll have this slider right in here. If you're in 2019, you'll have a drop down arrow where it'll say resolved, lightweight, large assembly mode, or large designer view. They changed it now in 2020 so that you can use large assembly settings even in resolve mode, or lightweight mode, or LDR, or large designer view. And in this case, I'm going to check this box right here, edit mode. So if you're not familiar with this, I'll cover this again here. The idea is that we can load up this assembly here instantly. And what we can do is now I can choose to insert in a lot of new components in here. So for example, let's grab this hose. I want to insert in this hose. And I know this is not a practical example because I picked a random file, but what we can do is not only can we insert in this large design review edit mode, I can also do mates within here as well too. And then on top of that, I can even do, I should be able to do alt drag here as well. But again, I can mate, for example, faces to faces. And now we've got this part right in here defined. And again, now you're going to see right in here how this is called. That can make a big difference. But icon saying, hey, this assembly is now at a date for the graphics. It needs to be updated. But again, this allows us to very quickly open up these can be quite large assemblies in this large design review edit mode. Pattern components, insert components, mate. We can also do section views within here, for example. So it allows a lot more flexibility now within the performance aspect of things within your assemblies. Then when you're ready to, I know a lot of our customers will look at this and say, okay, that's great, but I have to also work with my sketches and resolve components. Then we can look at either resolving selected components, or let's assume, for example, you made a whole bunch of updates either in your top level or your subassembly. Now we can say, for example, in here, set all to resolved. So you can make a whole bunch of updates. And if it does take a long time to load your assembly, then you can go for your coffee afterwards if it still does take a long time to calculate. But this should help out in terms of performance to, again, further help you to optimize to get more stuff done in less time. So that's large design review edit mode in a nutshell. I'm just going to save this here quickly. And now I want to cover detailing mode here for the drawing side. So if I go over here now to the drawing side, let's launch this guy in here and let's load this up in lightweight mode. So here we've got our existing drawing, and you'll notice this open process indicator. I highly recommend everyone really interested in this, as this will show you how long it's taking to load going through each of the sections. So if you are seeing it's taking a long time to load up your drawing within here, it's going to click Save All. Sure, I'll update my views. then what we can do is, instead of loading this up in lightweight mode, we can choose this new option here called detailing mode. So in detailing mode, this allows us now to load up our assembly. It will not load the update. So for example, had I not done loaded in lightweight, hit save first, and I just loaded this up in detailing mode, this component would not have shown up right now. So it would not be in the up-to-date state. What it does allow us to do is go into our annotations, allows us to do our smart dimensions, for example, within here, add in any other notes that we might need. Balloons, for example, we can add in here as well. Surface finish and weld symbols, and so on and so forth, right? So here's detailing mode. And then if it is a very, very large assembly, what we can do is we can do a save without resolving, which is faster. So we can save with our updates. And then if we do need to load it, we should be able to then, if I do a right mouse button, I can do a Control Q, and I can now open up my assembly. That was in detailing mode, and now it's saying, hey, open and resolve mode. So Control Q now will force the update to the sheets. And this is one way now of how I can work with our drawings, right? Where now I can add in a bunch of annotations, then we can push the update afterwards if it is a very, very large file. Okay, and now there it is updated, and away we go. And now another thing with drawings too that we can also do is that if you have a multi-page drawing, because I know sometimes some of our customers will have 50-page drawings, we can use the select sheet option, and we can load only specific sheets. So for example, if you have a situation of where you have maybe 50 sheets with a lot of section views, I highly recommend only loading the sheets you need at a time. So for example, right now I'm only going to load up here just the first sheet in resolve mode, but the second sheet here is only going to be loading up just the graphical information. So again, this allows us to make changes to our drawings here a lot more quickly. Again, but now you'll notice in here we don't have our annotations, so maybe if we know we do need to add in some notes, what we might want to then do is then say either A, load sheet, or if it's just an annotation change and you know it will take a while to load said sheet, maybe close it and again relaunch it in that detailing mode. So the other thing here, which I do want to cover briefly, is the task pane here. So I'm going to launch up my barbecue again here in my assembly. You notice right now it's currently triggering a save. There's one tool which I do want to mention for helping to investigate, as this isn't really documented in very many locations, but it's worth noting. And that's from the right-hand side, you'll see this file folder here for File Explorer. Open that up. And then there's this option right here for Open in SOLIDWORKS here. So I'm just going to pin this open. And if I click on Open in SOLIDWORKS, what we can see is we can see all the files here which are loaded. In this case, you'll notice right here, there's this orange file. So if I zoom in here, you'll notice here I've got this pan crosshead part, which is currently orange. This is indicating that's a read-only file. So in this case, I can see it's coming from my SOLIDWORKS toolbox here. So orange is indicating read-only. And what I want you to also notice here too, is that I also have this full grill assembly that's bold. So this is indicating that there's some sort of change that happened top level in my assembly, but it looks like all my parts, there's no change happened in here. So again, this allows us to see if there's any updates that are happening in here, and this is particularly useful. If you ever see anything bold and orange, that would then potentially indicate that you have either an older version or it's configuration being referenced that's read only and will trigger a rebuild every time your assembly loads. So again, this will allow you to, if you do want to investigate further, this is one extra very useful tool in terms of investigation. But we're going a bit off on the side here. Now I want to get back to the key areas, which is working again with our tools here. So again, now we have our macros. So, okay, right here. So here comes the best part of this whole presentation now, which is these macros, freeze rebuilds. So this was not developed by CAD Micro. This was developed by somebody over at CodeStack. And let's up this here. And this macro is incredibly useful, and I'm still finding the benefits with it. I still haven't found all of them yet. It's very simple in code. I highly recommend everyone should check this out from CodeStack. If you would like a link to this, I'll send it to you out afterwards. And you'll notice right here for the code, this is it. This is all this is. So if you're looking at what this code actually does, we can ignore sort of the first part because it's not really doing a whole lot. All we're doing right here is this is just a button click. And here we have the actual user form. And specifically within here, all we have is a very basic if statement, which says if there is no model, then it asks you, please open a model. So if there is a model, all this is doing, right in here, it's saying, okay, it's looking for the part. And then all we're doing down in here is we're saying cancel regen. So all this cancel regen function does is quite simple in terms of its goal, but it's very powerful in what it does. So that's the code kind of in a rundown right here where you see it's cancel regen. So the best part about this now is I'm going to run this macro. Let's see, it's going to go to my desktop, go to my freeze rebuild. That's what I called it. You can even add in a button up top in here. I'm just showing it from the loading in 7 minutes, removing all the, and I get this button right in here. It says rebuild operation suspended. Click the button below to exit the mode. So this will now allow me to do is here, if I, for example, let's say I want to hide this component. So now I want to edit this rack within here. So let's say in here, again, I'm going to rerun this macro in here. So you need to make sure it's running here for the active file. And now let's say, for example, here, I've got a very complex part with a pattern here. It's going to take forever here to update. So what I'm going to do is I'm going to change this 18, make this 10, click OK. And it looks like it did update here. So let me exit out of this here. I'm going to rerun this again, just to make sure this is working. So let's try this pattern again here. So if I go edit, and let's make this 8. There we go. So now it's working as I expect here. So at this point in time, what you'll notice is that this just graded out here, but we're not seeing the update happen in here. So what we can now do is I can now do a save, and I can choose to save the document here without rebuilding. I can now close out of this cook rate. And you'll notice right in here, there's a cook rate again. So again, let's close out of this right within here. And I'm going to say here now, don't save. And I don't want to save in here either. So now what I want to do is I want to relaunch that same cook grade again here. But what this is allowing me to now do is it's now allowing me to make updates without having it rebuild during the action here. So here it is right here where it's already rolled it back here for me automatically. And if I roll this back down and I hit my rebuild, now we're seeing, now it's pushing that update. So again, this allows us to now make changes to either our part files or our assembly files without having to do a rebuild all the time. So another example is I have this sketch within here. My dimension's really far away, jeez. Okay, so let's say, for example, I got this 0.125 right within here. And now I want to make this, let's say it's too small and I'll make this larger here. So I'll make this here now 0.5. You see the sketch size here update. I'm now going to exit out of my sketch. But you'll notice here the diameter hasn't actually changed at all, right? It's still the same. So now so the idea is that this now allows us to make multiple changes here to our files without always having to go in and hit rebuild all the time here, which can be a big time saver. So again, now for working with our very, very large assembly, I know some of you work with skeleton sketches or top-down level sketches. So now we're able to make updates to multiple things at once here without having to do a rebuild. And then again, I can do a save the document without rebuilding, exit, and then we can either push the rebuild for next time, either I load the assembly. So for example, if I now launch this in resolve mode, we can then push the rebuild at that point in time in here. And you'll notice right in here, now the cook rate now shows up right in here as bold as indicating there's a change. And it's going to request a save. And if we take a look, there's here, if I unhide my cook rate, so it looks like I hit it by accident, we should see that updated size. But so this is one of the main tools within here. Now, another advantage to this freeze rebuild is with appearances. I mentioned earlier, appearances can have a detrimental impact potentially to your assembly. So now I'm going to launch this much larger assembly in here. And I need to make sure I launch this in large design review mode. Otherwise, we'll be here about all day waiting for this to load up. So here it is here. So let's launch this part file. So if I launch this part file first, it's going to load very, very quickly. Then I can launch the assembly. But the main focus here is the part file in and amongst itself here. So it will take a few seconds to load because it is almost 100 megabytes in size. But in this case right in here, you'll notice we have some appearances applied right in here. We also notice right here, we've got over 5,000 bodies that exist here. So we've got a lot of bodies that exist in this file. So if I do a rebuild, this will take a while to load it into memory. Here you know you've got a file which has lots of appearances and you want to remove all of them. If you're to do the right mouse button up top in here, go to your appearance, and let's say, for example, you identified one you want to remove all of them from. If you just click this as it is, at least in this particular file, it will take more than 1 hour for it to remove all of the appearances, which is crazy. It takes a long time. But if I run that freeze rebuild, and here, then I do the same thing. I won't do it right now because it still takes a while to run through. But it took that 1 hour calculation time down to roughly 2.5 minutes. So again, quite a substantial time difference. As to what's happening in the background, I'm not quite sure. But again, this is another reason why this freeze rebuild can be so useful. You can also use it too if you're launching your assembly. So if you do have an assembly and you want to make sure it's not going to be doing as many updates as possible, if you are quick, you can launch this before the assembly fully loads, and it should do a freeze upon loading as well too, which would also help. Again, that won't help for loading in memory, but if I switch back here to my presentation again, this update component right in here of any changes, it will stop all this rebuilding in here. Again, helping accelerate the time to get to this compute tessellation graphics triangles in here. Even though it's an out of date state, again, it allows you to make changes much quicker. And now the other macro that I have mentioned in here is one for remove all part appearances. So if you know you have a file where you have lots of appearances in here, I highly recommend you could always use this macro too, and you can run this list, remove all the appearances within a particular assembly. So if you don't want to remove the appearances from all of your assemblies, you can always remove it from specific ones as well too, like take the parts, insert it into a new assembly, run this macro to then remove it. So, and then if we go back to SOLIDWORKS in here again, and then if we were to take a look at this assembly, this test MSE in here, in the large design review mode, because I don't want to load this up here fully. And while that loads here, actually, because it still will take a little bit of time, I do want to mention right here, CodeStack. I highly recommend everyone here that's watching this webinar does check out CodeStack. There are a lot of free macros that are on here. Some of them are very, very useful and can be very powerful. For example, delete all equations. There's a suspend rebuild one. There's also a suspend graphics update too, which also might be useful. And then amongst various other ones in here as well too. There are a lot of macros in here I do recommend that everyone should check out. Maybe there's one in here which you will find useful. Yep, let's try this again because it looks like this is not loading. Right, okay, so let's change this up here and let's load up this one in large designer view mode. There we go, okay. So from within here, what I wanna do is just to help increase the opening time of this, we can take a look at the total file load time here because I do wanna mention one more tool in here just for in terms of the investigation. So I'm going to load up this part file first, because if I load up this assembly file right now, for some reason, it will take several minutes to load. So that open process indicator I mentioned before, I highly recommend everyone keeps mindful of what that indicator is doing as it's doing its load, just to see, is it hanging on a specific component? For example, there's a massive assembly that this file is associated with. It would hang on here for a while. And if you try loading that part file first, if it is hanging on one, then switch over to the assembly file. It might load significantly faster for you. And let's switch back over here to my assembly here. And now let's set all resolved, because this will now resolve here fairly quickly. Now, if I go over to evaluate, I do want to briefly mention here performance evaluation, where again, we can take a look here at our open performance. And then we also have in here display triangles. In this case, there's almost 1 million. We've got shaded parts quality, anything here with regarding rebuild. So it's saying there's no mates, settings, and again, here too, this will sort of help you to find, okay, how many bodies do I have? How many unique part files do I have? And how many total components do I have in here? And so on and so forth. And this will, again, will sort of help you to narrow down your investigation if you are faced with slow assemblies here. And then you also have assembly visualization, where we can filter here by graphics triangles, the open time, and then that's the rebuild time of the part. This does not matter so much in terms of the assembly. And the reason why is because right now I can hit rebuild, but you'll notice if you take a look at my rebuild counter here at the very bottom, it says currently says rebuild, it's 3. I hit rebuild and now I see it update to 4, but this 47 seconds did not count. And that's because we're not making any changes to that particular part file at all. So it's not going to have any effect. So again, I don't recommend to look at the rebuild and focus on this one at all. Focus mainly on this open time and total graphics triangles time. And then again, and quantity is a total including graphics triangles. Okay, so let's switch back over here. So this is a sort of a shorter presentation. So now, does anyone here have any questions?
Awesome. Thank you so much, Ryan. We do have a couple questions in the queue, and like Ryan mentioned, we do have a few more minutes in case anybody has any additional questions. Go ahead and type them in. But let's go ahead and get started with what we've got so far. So we've had a couple questions actually, Ryan, on where everyone can find the macro that we're showcasing here.
Right. So if you want to find a macro, you can either do a Google search or we can send a link out to you afterwards. And you want to look for code stack. And then if you search for code stack and in SOLIDWORKS, you'll find the list to find a whole bunch of macros. And this specific macro is called macro to remove all, oops, wrong one. So the performance one, suspend rebuild, is called macro to suspend rebuild operation in SOLIDWORKS model using API. So feel free to either screenshot this within here, or we can send you out a link to this afterwards. Again, this was not developed by CAD Micro, but I highly recommend that everyone should be using this particular macro.
Great, and yeah, I'll just add on that point there that we will include the link to that when we send you the recording of today's session, which you'll receive tomorrow afternoon. Okay, so Ryan, the next question we have for you here is, does updating to 2020 improve slow assembly performance?
I have seen in some cases a significant difference in performance loading and opening with SOLIDWORKS files. Specifically, SOLIDWORKS has updated the code so that if you have a configuration which is already in a rebuilt state, and let's assume it's in 2019, SOLIDWORKS will not be rebuilding that configuration information in 2020. So again, if you have old files, SOLIDWORKS 2020 will help them load faster, and even some assemblies from 2019 updated in 2020 will load even faster. It's not always the case, but I have noticed it has been significantly improved overall.
Okay, great. Thank you, Ryan. I think that's all the questions that we have in the queue. There were a couple of repeats there, but you've, I think, answered all of them. So with that in mind, as I mentioned, we will be sending you the recording of today's session via email tomorrow. If any questions do come up between now and then, feel free to either reach out to your account manager or you can respond to that GoToWebinar email, and we'll put you in touch with Ryan or somebody from our team that can help you out. We'll also be sending you a little information on some additional webinars and complimentary online training sessions that we have scheduled over the coming weeks. Those will be covering all sorts of different SOLIDWORKS and 3D experience topics. If there's anything in mind, any particular topic that you'd be interested in learning about, we would love to know. You can reply to the GoToWebinar email that you'll receive tomorrow, and I'll do my best to get that penciled in so we can cover those topics in the very near future. Once again, Ryan, thank you very much for a great session, and thank you to all of our attendees for spending a little bit of your Wednesday afternoon here with us today. Please stay safe and stay healthy, and we hope to see you again very soon. Thanks.